let's read through the question. A vertical plate is submerged in water and has the indicated shape. In this particular example, it has the shape of right triangle. Explain how to approximate the hydrostatic force against one side of the plate by a Riemann sum. Then express the force with an integral and evaluate it. So this is pretty much what's going on. You have a plate, 2D, and you submerge this plate in water, right? So it doesn't actually matter what side they meet, because you will have the same pressure here and here. So this is actually more clear than the problem we solved on Friday. Okay? So since we're asked to find force, obviously we will need the pressure and the area of the plate. And since the depth is changing as we go further down, we'll have to use a thin slice on the plate and then set up the Riemann sum. So then let's start with picking a thin slice on the plate. And let's call this guy has the width of delta x. Maybe you might want to sketch it. This is a thin slice. It has the width of delta x. We know that this is 10. This is 5. We don't know this length yet, so let's call it W. We don't know what it is. So we will need to figure out the area of, let's call it height strip, and the pressure on the height strip. Obviously, if we're using Riemann sum, we will have to have a diagram. This is where the water starts, 0. We know that this length is 2. So, and we know that this side is 5, so then the plate ends at 7, right? And we picked a strip somewhere, we don't know where it is. Let's call it xi star. So the area of the height strip is going to be, this is a very, very thin rectangle, so it's going to be length times width, it's going to be W times delta x. And what about the pressure on that particular strip? What is the pressure formula again? Density times gravity times the depth, right? So what is the density? So since the units are in terms of feet, we can just use 62.5, the water density, the weight density of the water, and then we need to multiply it by the depth. What is the depth of this strip? This corresponds to xi star, right? So then the depth is going to be xi star. So we figured the area of the ice strip and the pressure on the ice strip. The problem is we have W, and W is not in terms of x. How can we express W in terms of x? We will need to use similar triangles. So let me sketch the triangle here. We know that this is 10, this is W. What about this length? It's from 2 to xi star, right? So can we just write xi star minus 2, right? This is the vertical distance, and it corresponds to the distance from 2 to xi star on the diagram. So if you're trying to calculate this distance, since xi star is greater than 2, you need to subtract 2 from xi star. And what is this length? It's 5. So then we have two similar triangles. The smaller right triangle, xi star minus 2 and W, and then 5 and 10. So if we set up the ratios, we can say the ratio between xi star minus 2 and 5 should be equal to W over 10. Yeah.
When we were doing the pressure on the strip,
Yeah.
why do we not multiply by gravity?
Because this is, units are given in terms of feet, right? What do you know about feet? The motor weighs 62.5 pounds per feet cube. And you know, this takes care of the gravity. This is the weight density,
Okay.
right? I think we use epsilon to represent that. So if you're using that, you don't need to worry about gravity. This is pretty much gravity times density. So if the units are given in terms of feet, you can just use, and if you're given this fact, you can just use the weight density of water, which is the gravity times density, and takes care of the rho times g, and the only thing you need to multiply this by is the depth, which is xi star. Any other questions so far? So how can we express W in terms of xi star? Can we simplify 5 and 10? And then use the diagonal product. The W is going to be 2 times xi star minus 2. Do you agree with that? Now, I think we're ready to set up the Riemann sum for the force. F equals P times A. So it's going to be the pressure times, say F equals P times A. The pressure times the area, and the area is 2 times xi star minus 2 delta x. And now we need to turn this into an integral. The plate is from where to where? We're trying to calculate the pressure on the plate, right? So then we need to see where the plate starts. It starts at 2, and where it ends at 7. So we'll have the integral from 2 to 7. We can pull these constants out. 62.5 times 2, which is 125. From 2 to 7, we have x times x minus 2 and dx. So we'll have 125 outside the integral. And if you distribute x over x minus 2, we would get x squared minus 2x. And if we integrate x squared and 2x, we would have x cubed over 3 minus x squared from 2 to 7. If you plug 7 for x and then 2 for x, you will get 25,000 over 3 pounds. Since you're not allowed to use calculator in the exam, you can just plug in and leave it like that. You don't need to get the final answer.